Hey, my name is Connor. I'm with Agathon Solar. We are here in beautiful South Haven, Michigan, specifically on Lake Michigan. Today we're going to give you a tour of our recent solar PV, wind, and battery energy storage project for Yenelle Conservation Habitat. It's a wonderful sunny day, June 3rd of 2026, and we're excited to give you a tour of what we put together. So come along and follow me. All right, so here we are outside at our solar PV array. This array consists of two sections, one section facing southeast to capture more of that morning sunlight, morning energy production. The other section faces slightly more southwest to capture more of that late afternoon sunlight and energy production. This array consists of 126 bifacial solar modules. These are 540 watt. Again, bifacial modules, bifacial meaning that these panels on the back side are clear and they're able to capture additional sunlight that's reflected off of the ground, improving the overall energy production of each panel and thus the entire array. Also, these panels are equipped per panel with a TIGO optimizer. These optimizers allow you to monitor and view each solar panel at a panel level, seeing which one is producing how much. It also allows you to bypass any shade. If one panel in a string is shaded, the other panels in that string are still able to produce at maximum energy production levels. So again, this is 126 70 kW total of solar energy facing southwest and southeast to make up this solar PV ground-mounted array. All right, so now we are at our wind turbine portion of this project. We have 3 wind turbines here. Each turbine is an SD6 wind turbine for a total of 6 kW power output per turbine. These are 30-foot mono tilt poles. On the top we have 3 horizontal access blades. The tops of these wind turbines are able to spin in a 360-degree angle to capture the most readily available wind at the moment to maximize the energy generation from, again, each turbine. So for a total of potentially 18 kW worth of wind energy, wind power, these 3 turbines are able to contribute to the overall system. Today I wanted to walk you through the mechanical room of our recent solar, wind, and battery energy storage project. So there's 4 sections to this mechanical room. The first section is our wind turbine inverter section. Our next is the electrical infrastructure. The third section is the solar PV inverters. And the fourth and final section is our battery energy storage section of this mechanical room. Here in our first area is the wind turbine inverter portion of this project. So here you can see 3 Sol-Ark 5K inverters. These are hybrid inverters. We have 3 wind turbines outside. Each turbine, number 3, 2, and 1, land into each inverter. With these inverters also comes a turbine and inverter controller unit, as well as a dump load resistor. So here we have the wind turbine combiner panel. This combines the wind turbine energy here. As you can see, we've got our 3 2-pole breakers, 1 for each Sol-Ark 5K unit. That electricity then travels over to our 2-pole double throw switch. It passes through here when our transfer switch is in the normal position for wind power, and it travels to our Sol-Ark 30K inverters, at which point the power is distributed to either the home, the essential loads for the home, the battery energy storage units, and in the case of excess energy generation, is exported back to the grid. While we're over in this section, we have our mentioned essential loads panel. This is protected by electronic magnetic pulse shield, so EMP shield protected. This panel hosts all the essential appliances for this home. Now here we have our solar PV combiner, similar to the wind turbine combiner. This combiner takes in the power of both Sol-Ark 30K inverters. these two breakers here. And again, is distributed similar to the wind turbine combiner panel to either the batteries to charge those, provide power to the home and the essential loads panel, and again, in the event of excess generation, exported back to the utility. Speaking of solar PV, these are our two Sol-Ark 30K 208 volt hybrid inverters. Each inverter hosts one of the two PV arrays that is seen outside, the west and east PV array. Again, similar to the wind turbine Sol-Ark inverters, these two Sol-Arks will take in the solar energy, convert it to usable electricity, and then is distributed evenly throughout the home, the batteries, or excess energy generation to the grid. So moving on to our final portion of the mechanical room is the battery energy storage component. These batteries each are 60 kilowatt hours of battery energy storage. Two battery cabinets are delegated to one of the Sol-Ark hybrid inverters. So the four batteries here combined offer a 1/4 megawatt of kilowatt hours of energy capacity to provide backup power, store excess solar or wind energy generation, to provide power to the home or the business. So a great benefit of these batteries is that when the grid is up, the batteries can allow you to use less energy from the utility company, thus saving you money on your grid-tied system. In the event of a power outage due to weather or some other event, these batteries then provide backup power to power the loads of the home or the business. So in the event of poor weather, which we see here in Michigan, whether it's low sunlight, not a lot of wind production, and the batteries are at their depth of discharge, you can switch this manual two-pole transfer switch down to the generator port. That would allow a generator to then provide backfeed power to recharge these batteries and to provide power to the loads of the building.